Hello everybody, my name is Chris Hulme Smith. I'm an assistant professor at the KTH Department of Materials Science and Engineering, and my area of expertise is in the production of metal powders. And that's what I'm going to talk to you about today, how we can use the production of metal powders as a way to protect ourselves against problems with the supply of critical raw materials, especially those required for electrification and digitalization, and also save energy. Okay, so as you can see by the title of my presentation, I'm going to be talking to you today about making metal powders from critical metals and how that can lead to sustainable digitalization. And what is it about electrification and digitalization that leads to this requirement? Well, the first is that we're going to need a lot more metals of types that we haven't really needed in large quantities up to this point in the same kind of way. So of course we use a lot of copper already for electronics, but if we want to electrify a lot more things, especially high powered things, we're going to need a lot more copper. And also things that are even really scarce, like cobalt, where most of the world's supply comes from one country, and if a natural disaster happens there or some kind of geopolitical problem, the supply is threatened, and that could have huge implications for everybody in the world. And that's used for things like lithium-ion battery terminals. It increases the efficiency of other batteries like nickel cadmium, and it's also used in some very strong magnets, samarium cobalt magnets. Another example would be indium, which in the form of indium doped tin oxide is used in touchscreens pretty much everywhere, and also as the base material for solar cells. Neodymium is also extremely rare, classified as a critical material by the European Union, and that's used in neodymium ion boron magnets and also a lot of different kinds of laser. And gallium often forms very useful band gaps in semiconductors, gallium nitride, gallium arsenide, close to optical wavelengths, and so it's got a huge application in LEDs and solar cells. Everything there except copper is in critical supply. And it will threaten digitalization and electrification, which will contribute to the 4 United Nations Sustainable Development Goals on the screen. Hopefully by the end of the talk you'll understand how we can help with that. So what is the proposal? What are we suggesting? Well, firstly, we're going to take all the waste in Sweden and we're going to extract all these critical materials, maybe some non-critical ones too. For example, in waste electronics, we can take out a lot of the critical metals from there, and also other metals, like people throw away a lot of copper, a lot of aluminium. We could even recycle those in the same way and turn them into powders. And the motivation of turning them into powders is that you don't need as much material to have an economical process than you do if you're making bulk ingots. It also opens up the door to manufacturing routes that require metal powder, especially additive manufacturing, and that's where a lot of excitement lies at the minute. That also gives you the access to these technologies, which generally require less energy than traditional manufacturing routes. We then use those powders to make new things. We could do all that in Sweden. Okay? Because we already have a good municipal collection infrastructure in Sweden. There are a lot of recycling stations where people can take electronic waste, and you can also drop it off at the local hardware store quite often as well. If a company goes in and installs things like new routers or new motors in a factory, they often take away old components as part of that service. Those components can be recycled too. We already have the facilities to sort and process this waste within Sweden, and definitely we have the infrastructure to produce metal powders, I promise you that. Sweden produces about 25% of the world's metal powders today. We also have a lot of companies that can take this powder and do really clever things with it. In literature, there are examples of using additive manufacturing to create batteries, and also to 3D print sensors directly into other components, making the component and the sensor with additive manufacturing and making it in a way that can't be made traditionally. All these actors exist. What we want to do is bring them all together. Where do the energy benefits come from? Well, with powders you can make things that are almost in the final shape. You just need a tiny bit of finishing to get exactly the right shape, rather than starting with a large block and cutting it down and grinding bits away, all of which has to be either wasted or recycled. Therefore, we reduce our materials consumption, reduce our energy consumption. We can make components that can work in a more energy efficient way. For example, in a car, something that could be lighter and yet do the same mechanical job, saving fuel. Again, an energy saving, especially if we have electric cars. We can do manufacturing without melting the powders in very many cases, but even if we do melt the powder, we only melt it where it's needed to be melted, rather than melting all of the volume of our metal and casting, for example. With 3D printing and other powder-based processes, you can manufacture lots of different components in one facility rather than needing very specialist equipment to do every single component. That means you could have a lot of local manufacturing centres using this reclaimed powder to produce new components, all on a local level, definitely all within Sweden. That's going to reduce transport costs and energy expense in that sector as well. And of course, if we get the market right for this, we could expand the idea to large volume non-critical materials like aluminium, copper, steel, things that require huge amounts of energy today and are very polluting. And with that, we can definitely contribute in lots of ways to all of those United Nations Sustainable Development Goals that I introduced at the start. If any of that's been interesting, please get in touch. I'm very, very happy to talk, and I hope to hear from you soon.